Welcome. My name is Richard. I'm part of the IT team supporting our finance department. I want to talk to you a bit about how we process financial transactions, what it means to be wrong, and well, what the impact is if we're wrong. I want to start off with this item. This is a trampoline spring, something we sell at our shop. So if you're a bit too enthusiastic when jumping on a trampoline and you need replacement parts, we got you covered. And being a financial system, we track our profitability. So this is something for this particular spring, how it might look like. So in January, not too many jumpers. In April, May, we get a bit more. I'm going to show you how May looks, because in May something interesting happened for us, May 8th specifically. So pay attention, you'll see a slight increase. So we increased 60 million in revenue on April 8th. So one or two things might have happened here. Either one of our buyers did an incredible job and, well, he met his target, or maybe something went wrong. The setting for the buyer is that it was the latter, and we actually traced down what happened here, and we traced it back to a single transaction. So a single transaction actually told us that our warehouse received 8.7 million of these springs. Now, in my mind, this means Waalwijk, where our warehouse is, has loads of traffic problems because there are loads of trucks with a lot of trampoline springs. So they assured me this didn't happen, and what actually did happen is when we looked a bit closer into this transaction, is the number is sort of, it looks familiar, especially if you're working in logistics, it might look, the first couple of digits might look a bit familiar. And when we put the EAN number there, it actually shows a happy coincidence. So what probably happened is at our warehouse, someone entered an EAN code in the quantity field. All right, 60 million, it's a good thing, right? So what does this mean for our systems? Because every system happily agrees that this is a valid transaction, right? We have a quantity field, it has to be a number, 8.7 million is a number. All right? Well, still, we need to correct this, and we need to fix our wrongdoing, our error. So what do? We send a counter transaction. So now we don't have one peak, we have two of them. Okay, so in our books, actually, this is fine, right? Plus 60 million, minus 60 million, it balances out correctly, all good. However, if you want to do analysis on our data, which for our sales data, it happens for a lot, you might see some weird artifacts if you don't take these kinds of incidents into account. So for example, even though the accident happened on a Wednesday and was corrected on a Friday, if you want to see our sales per day of the week, you still see the error, even though in our books it shows up as 0, which is awkward. These kinds of problems are annoying to work with, and they dirty our data. You don't want these. So is this wrong? Well, I hope you agree with me that this data, this peak we're seeing here, it's artificial, it's wrong, it shouldn't be there. However, as I mentioned, all of our IT systems happily agree that this is a valid transaction, right? You wouldn't put a rule in your service that says when 8.7 million trampoline springs go by, don't accept this record, right? You build functional systems, you build them to spec, but not every system in our landscape should worry about these details. But at the end of the day, we don't want this data, right? We do want some sort of filtering on this and some sort of hints to what is happening here. And that brings me to what I think is in data quality is a good distinction to make. So it's a distinction between something that's functionally wrong, right? Our IT systems worked correctly here, but the data was wrong. So our input was wrong, a functionally error occurred. And on the other hand, we have technical issues. So what if you have bugs in your systems, or maybe your infrastructure has been delayed? Like technical issues, I think we're good to solve. Like we have a lot of metrics, we have a lot of alerting that says, is our uptime correct? Is our throughput of data correct? I think functionally we have ways to go, and especially in the service where I work, where we're looking at financial transactions, We're really good in saying, okay, did I process all the data I received? We're a lot less good in saying, those trampoline springs, there are an awful many of them, should we accept it? All right. So this incident occurred, and we got to thinking, how can we increase our reliability of the data? How can we increase our data quality? And we want to measure it, right? We don't want to work on a gut feeling. We want to measure our data. We want to see what is correct, what isn't correct, and we want it presented to us. So how do we go about this? Let me tell you a bit about how our service works. So our service is a Flink job. It's a piece of software that gets messages from the one side, it processes them, it joins them, it enriches them, and then it outputs it on the other side. We're all happily going to the cloud, meaning pops up is our wave transport. And this has some nice features, especially in our bol.com landscape, where we started to move toward the cloud, meaning our data is also stored in a really scalable way. BigQuery, for example, a lot of the data that we process actually has BigQuery tables, meaning that we can actually process them and read them and verify our results without touching our main process function, right? So without touching any of the operational stuff, we can verify what was our input yesterday and what was our output yesterday. And do those match up? Like, have we processed everything? Have we done everything correctly? And haven't we had big transactions like 8.7 million trampoline springs? So something like this might occur, right? We have two BigQuery tables, one of our sources. Maybe it's an inventory system. We have our own output. We match them together. We see, did we process every transaction? Was everything processed correctly? We verify them, we check them. Maybe we want to check our own input data. Did we get any large transactions? Stuff like that we can really easily check now because our data is readily available in BigQuery, and it's in a scalable way. Even though we process a lot of transactions, it's easy to figure them out. In practice, this actually means we just write SQL statements, just queries. We join the data up together, and we check them and see what happens. Easy stuff so far. Easy enough that it becomes boring to do. And as an IT team, we started to automate this because it's fun to do it a couple of times, but then, right, we want someone to take care of it for us. So we built a little service, super simple. We built it in a hackathon in a day, improved upon it a bit later, but the essence is it just runs our queries daily, right? The queries is where a lot of our domain knowledge is in. It's something we don't really write ourselves, but business writes, our business analyst write it, our product owner writes it, right? So it's the people that actually know what should the system be doing, what are the weird things it should be doing, and how can I check it? How can I verify that it's correct? So something like this might happen. Daily, it verifies our tables, it verifies our input, our output, checks what happens, is it going right? It shows us in a nice little table, and this is accessible for everyone within bol.com. It shows what did we do right, what didn't we do right. It shows it a bit, at what time does it happen. So an incident that happened a couple of weeks ago is where every time at around 1 o'clock, we're missing data. So what actually happened is one of the systems got overloaded around that time, and we started losing data. And we figured out which system was causing the problems, and we fixed this. But it gives hints to what kind of patterns might occur and why stuff might go wrong. Now, dashboards are fine. Again, we don't want to look at those. We'll output metrics. So metrics allows us to do lots of funny things. It allows us to show things on our TV at our desks. So we'll get a red flashing warning if something goes wrong. Maybe we'll put iris there. So you could think about having chat messages in Hangouts. You could think about having, I don't know, even SMS alerts if something goes wrong. And we're also playing around with Jira. So if something does go wrong, we'll have an auditable log in Jira showing what went wrong, how did we fix it, so we can actually review it later on. I want to end with this slide. So we're, as a financial system, we don't produce any data, right? We just take a lot of data, we read from a lot of other services, and then we output the data. This means we're heavily reliant on your services to actually produce correct results. And I would encourage everyone to think about their own services. Like, don't trust what your service is outputting without verifying. Measure it. Like, have your checks in place to see my service is actually outputting the correct data. Data that might not be the primary responsibility of your service, but is outputted for reporting, for business, for financial transaction systems maybe. Technical and functional checks. I think, again, technical checks we're pretty good at, I think. Uptime, seeing that the system works as it's supposed to, I think we're pretty good at it. Functional checks, as I've shown you in the start, there is an advantage to verifying those results and seeing them early on. Start small, easy. We started in a hackathon. We worked with a couple of queries, just verify roughly, do the amount of euros make sense? Do we have very large quantities? Just start small, and at some points we're sort of rebuilding our application in queries, which may seem a bit awkward. But once we started small and we started gaining extra information about what is actually happening in our system, it showed us a tremendous amount of insights in what our application is doing, what is the data that we're outputting on, and in the end, what is the data that our business users are making decisions on. I want to close with this. Thank you. Any questions? Yeah, sorry.
Can you say something about the costs of the functional checks?
Yeah, good question. Tremendous. I'm glad we're a financial system, so we actually have a bit of control there, but no, initially they were extremely high, right? Google is good in sending invoices, and well, but there's iterations there. So what we initially did is we checked the whole data sets again and again. Now we're incrementing in. Maybe only what we processed yesterday is important to show us. Maybe only what we processed the last couple of weeks is important. Maybe not every column has to be checked, but we're fine if the euro amount is correct. So we're tuning there, but your instinct is correct. Initially it's, yeah.
I was wondering what happens now if somebody somewhere enters an EAN for Springs.
Yeah, good question. So we do have checks on these kinds of problems. They aren't our main focus. Like after incidents like these, we check how often does this happen, how often does this show up. And what we actually notice is that business, for the really big ones, they have a pretty good feeling of what happens, and it gets corrected usually at the end of the fiscal period, right? So every month, they actually see the upticks, and they will get corrected. So we're working on checks like these, specifically these checks. We would see them in our dashboard, and they would get corrected in exactly the same manner. But there's room to improve there. I think it should go to the front. But that's a difficult problem. That's a priority problem, I suppose, for sure. Any other questions?
Do you have time for one more question? None? Then I would like to thank you, Richard. Thanks.
Thank you. Cool.